The next topic we're going to look at is work and energy. And the first thing that we want to do is look at work done. And we define work done by a force moving or applying on an object or on a particle, and how long that force goes for times the distance that it moves. So Fs is really work done is force times displacement, Fs. And the units of force then are newtons and meters, Newton meters, but more often than not, we just call it joules. A capital J then will suffice for the units. A couple of different types of work done in particular. One is against gravity and one is against friction. And first we'll look at friction here. And work done against friction implies we need to overcome a friction. We know that friction has a frictional force which will act against the motion. And so if we push something for 5 meters, then the work needed to overcome that friction is the frictional force times 5 meters. So we have an example here. Horizontal force pulls a body of 5 kilograms, a distance of 6 meters across a rough horizontal surface with mu is 1/3. The body moves with constant velocity and the only resistance to motion is friction. Find the work done against friction. So here you imagine we have our body and we know that it's going this direction, and so there's a force here that's let's just call it X, that's pulling it across. I know that as it pulls across, friction is going to be at its maximum value. I know the weight of that is 5g, and the normal reaction there is going to be R. And so very like stuff that we've done before. Let's first of all, let's resolve vertically, and we see that R is equal to 5g. Now that helps us get the frictional force. The frictional force we know is got by the maximum value of friction, which is mu R. And in this case, mu is 1/3 and R is 5g. And so the frictional force there is 5/3 g. So the work done is equal to, against friction in this case, is the force against friction, which is mu R times S. And that's 5/3 g times, well, we're moving it by 6 meters. And that's overall, that's 10g or 98. Now again, we're talking work done here, so this is in Newton meters, or even better, in joules. So the work done against friction is 98 joules. Second main type of work done that we do is work done against gravity. When we pull something up, vertically up, then we have to do work to make that object move upwards. It takes effort to do that. And to raise a particle of mass m kilograms vertically at a constant speed, you need to apply a force of mgn newtons vertically upwards. If the particle is raised by h meters, then the overall work done is the force mg times the distance h, and so the overall work done is mgh. Work can be done against gravity when moving vertically upwards or when moving along an inclined plane, but not moving horizontally, because when we move horizontally, there is no vertical height to move up and down, so there is no work done against gravity. So let's have a look at this example. A particle of mass 5 kilograms is pulled at constant speed a distance of 24 meters up a rough plane inclined at 40 degrees to the horizontal. The coefficient of friction mu is 0.25. Assuming the particle moves up the line of greatest slope, find the work done against friction and the work done against gravity. Okay, so quite a common diagram to start with. We have a particle resting on an inclined slope. That inclination is 40 degrees. We have a normal reaction. We have a weight. And because it's being pulled up the slope, friction is going to act down the slope, mu r. And I guess we've some force x again that's pulling it up the slope. Okay. Now, again, To find the frictional force, the work done against friction, we need the frictional force. And to find the frictional force, we need to find R. So to do that, we're just going to resolve perpendicular. Again, I know that that angle in there is 40 degrees. So I can see then that when I resolve perpendicular, R is equal to 5g cos 40. And that ends up being 37.536. And that's a force, so it's newtons. The frictional force then is mu r, and that's a quarter times 37.536, which is, and that works out as 9.38 newtons. The work done against friction then is equal to the frictional force times the distance. Now, in this case, it travels 24 meters in the direction of the force. So it's 9.38 times 24, and that works out at 225 Newton meters, or even better, joules. So secondly then, that's part one, work done against friction. The work done against gravity. So I want to find is, well, how far up will this go? If it travels 24 meters up the slope, how far will it go? And so I know that, a quick wee diagram, here's 40, this is 24. If I want to find out how high up vertically it goes, I need to find that value h. And so you can see here that h is equal to 24 sine 40. So the work done against gravity is mg times h. Okay, our weight going vertically down is 5g, and then we raise it by a value of h, which in this case is 24 sine 40. So that's 5 times g times 24 sine 40. And again, when we put that in, we get our calculator, we get 756, and it's work done, so it's joules.